how do you get around building codes that don't see plastic as a structural material? Do you all have to add extra steel reinforcement in the walls and the floors and the roof?
So we have FEA models, so finite element analysis models, which give us the structural analysis of the entire building. And then for each, that's based on certain tensile strengths and strengths for the material itself. And then we prove that by having physical samples that are printed and then tested for their mechanical properties, so that we're effectively corroborating the entire structure from the FEA model analysis.
So you all don't need any sort of extra reinforcement while making these slabs?
It's just to kind of talk you through the process. So we print the whole structure monolithically. So there's no joints or no connections between parts. You might have seen from our design that we kind of have the, I guess from one orientation, it's like a capital D shape. Yeah. So at either end of the D, so to speak, we have open ends that we either fill with, we build that part conventionally. So we use steel stud framing to close the ends for the solid ends, and then people can customize. That's part of our release actually, so we're going to have a design configurator on our website where people can customize how much glass, how much solid wall, locations of doors and whatnot. They can customize that part of it. But yeah, in terms of the actual printed structure, it is purely the print itself. For when we've got scenarios where people do want to have completely open ends, where it's entirely glass, then at that point we have interior steel members that are kind of hidden within the print itself, but they're added afterwards. We see the whole efficiency as being the fact that we can print a structure that is self-supporting. It stands by itself within hours of being printed. So that day one print, and it takes less than 24 hours to print one module, we have a structure that's effectively watertight. It stands by itself. It's effectively having if you're comparing it with traditional construction, to have a framed, sheathed, waterproofed, siding finished, roof installed, any metal work to connect the walls to the roof, completely done within like less than 24 hours of printing, which is, I guess you're asking the question about plastic. That's another beauty of the fact that we can make that plastic structurals, because it adds the other functions that other materials don't have, such as being our membrane for the structure as well. So it kind of combines almost like 7 trades into one less than 24-hour print. So that's where we kind of see the efficiency being harnessed by 3D printing.
So last year I visited Mighty Buildings facility in San Francisco, and their structure is similar to yours. It's like a C shape with one, almost like a thinner wall on the other end, the opposite end. But their curve was printed with a different material and basically covered up with drywall and hand plastered. And what y'all are doing seems to be like y'all are printing this C or a D shape horizontally and then lifting it up to create the structure, and then the open ends are filled in with glass. I mean, depending on what the customer wants, it could be filled in with glass, so it's completely see-through. Mm-hmm. When you say that, then that's very interesting, because you're removing that manual labor that I noticed at Mighty Buildings facility, where they had to manually put up drywall and they had to put up siding on the outside. Like everything they had 3D printed was hidden inside the wall.
I mean, just to clarify, and sorry to interrupt, we still finish everything internally. So what we print for ourselves is, as I say, like the equivalent of a framed building. So it's ready then at that point for wiring, for plumbing, then we do a spray foam insulation on the inside, then we close it with a drywall and finishes on the inside. So the inside after the print is, at this point in time, we want to make it more automated, but at this point in time, it goes back to more of a manual installation. But it's that first part of the kind of structural creation from the 3D printer that is the big efficiency for this process currently.
So I really appreciate that you're using plastic as a building material, but if you're not using that as a final finish, then what steps are you automating? Because you said it's 7 trades in one, but what trades are you including in that? Because you still have to, like you said, add insulation after, spray foam insulation, and then drywall on the inside. You're finishing that out, finishing the seams in the drywall, spray painting that. And then what about the outside? Are you leaving that raw exposed plastic, or that's
So
also finished?
Yeah, the only finish that we apply on the outside is a coating, which gives us enhanced UV protection as well. So if it effectively gets painted after it's been printed, and that's all we do to the exterior. So the 7 trades are effectively, framing it, sheathing it, putting a membrane on the exterior, putting a roof on it, putting a siding onto the exterior, and then any kind of metal connections that you would normally have between a roof and a siding finish.
Okay, got it.
I was going to say it's the exterior that sees the biggest efficiency improvement from being able to 3D print with plastic, because the fact that we've made it structural, and then using the fact that plastic provides us with that waterproof and sealing membrane on the exterior, just takes away kind of all those trades, and not just the materials, but the time involved in installing them as well.